In the following section, I will introduce the eye simulation system. This system consists of three parts: cloud-based data storage, portable device, and the application on the device. Before we get into the details of those three components, let's get to understand how the system works first. This is the system flowchart showing the relationships and the functionality of three parts. First, the database stores all the images of objects using to produce the recognition classifiers. There are two ways to obtain those pictures. One is uploading by system administrator or uploading by user's device. Second, the portable device captures the images directly ahead of user for application to computing. Last, the application generates the object classifiers through the database and combines the captured images to feedback the voice instruction to the user. That is how the system works. Let's come back to the details of three components. The first one, cloud-based data storage, is used to store pictures. Those pictures tagged with categories named are classified by their name. For instance, there are several images of different types of cup, which will all be assigned to cup category. In a system, the portable device could be some kind of smart glasses or a smartphone hung in front of chest. The last one is the application. This application contains two modes: outside mode and home mode. Taking guiding tiles in our environment tends to put the blind people under risk. Therefore, the first function of outside mode is providing guiding tiles. When user walks on the sidewalk, the application will generate the virtual guiding tiles if the user steps out the range of guiding tiles. The application will warn the user and give instructions to guide him back. Another threat of walking route for blind people is across the street. There are two kinds of intersections when walking on the road. One is having the walk signal, the other is not. Our eye simulation system continues capturing images to process when the captured image contains a walk signal. The application processes the image, finding the signal, and then reminds the user there is a walk signal ahead, needing a cross street. Meanwhile, the system uses GPS positioning to overcome the condition that has no walk sign. When the distance between user and the road edge is lower than a threshold, the application also reminds user to be across road. Finally, the home mode is used to recognize objects inside the blind people's house. Before the first time using the home mode, the user needs to photo those objects which want to be recognized and uploads them to the database. Under home mode, the user says a command like find cup. The application will run object recognition algorithm based on the captured image. If not finding, the user can rotate for an angle and give commands again. These procedures should be repeated until finding the object or not finding the target in the space. All the above is the details of our eye simulation system.